Welcome back, everybody. We are now going to work on section 3 of our review guide. And this deals with factoring quadratics and using the factors of quadratics to solve quadratic equations. Some of the problems in this section can be done using other methods, but we're going to focus on factoring. All right, and so that's going to bring us to problems 3 and 6 from the review guide. And again, these are non-calculator problems. All right, so in problem number 3, you're given a situation where it says, suppose f of t is equal to negative t squared plus 12t minus 2, and that represents the height in miles of an enemy missile in a video game where t represents the time in minutes. Let g of t equal 4t minus 2, and that represents the height in miles of a decoy missile, which follows a linear path for the domain of 0 to 10 minutes. So if you think about this scenario, I've got an enemy missile that is following the path of a parabola that goes down, and then I've got a path of a decoy that is going to start off linear. Now I know that eventually that missile is going to have to decrease, so eventually it's going to come back down, but we're only going to be concerned about this missile for the first 10 seconds. And so if I think about my x and y axis, I'm only going to be concerned with the first 10 minutes. Okay, and so I'm not really worried about what happens after that decoy missile starts to come back down. And so what we're looking for is at what time after the initial launch do the missile and the decoy collide. So this is the point that I'm interested in. Now I know algebraically that my line and my parabola are also going to intersect somewhere over here. But this is what we're calling the initial launch. And I'm not interested in that point. I'm interested in this point up here where the two collide. And if you think about it, this is now just another system of equations that I can solve using substitution. I essentially want to figure out where f of t and g of t are the same. And so if I set them equal to each other, negative t squared plus 12t minus 2, I want to know where is that the same thing as my linear equation, 4t minus 2. Because this is a quadratic equation, and to solve any quadratic equation, you want to get it in standard form, I basically want to get all the terms on one side of the equation and 0 on the other. It also helps when I'm factoring if my squared term is always positive. And in this case, the way it starts, my squared term is negative. So what I'm essentially going to want to do is add t squared to both sides. Now when I add it to my other side, there's no other squared term for me to add it to. I'm actually going to do all this in one step because I also need to move my 12t to the other side and my negative 2, which means I'm going to have to subtract 12t, and I'm going to need to add 2. When I do that, all the terms on the left side cancel, and I'm left with 0 equals. And now I've got everything lined up. Notice that there's nothing that can be combined with my t squared, so it's going to stay t squared. I've got a positive 4t and a negative 12t. When I put them together, I get a negative 8t. And then notice that my 2's cancel as well. So I'm just left with t squared minus 8t. Well, we've been focusing so much on factoring quadratics that are 3 terms. We haven't really spent a lot of time looking at quadratics that only involve 2. And there are a couple different ways you can look at it. If I think about just a common term, if I undistribute what these two terms have in common, I can see that there's a t in both terms. So I can undistribute that t. The 0 is going to stay put. But if I factor out a t from both terms, the t is going to go out in front. And if I divide out a t from t squared, that's going to leave me with just a single factor of t. And if I divide out a t from negative 8t, that's just going to leave me with negative 8. And think about what would happen if I were to distribute that t again. T times t gives me the t squared I started with, and t times negative 8 gives me the negative 8t. But if I have t times the quantity t minus 8, I have the equation now in factored form. And once it's in factored form and set equal to 0, I can set the two factors equal to 0. That means I can set the t equal to 0, and I can set t minus 8 equal to 0. And so the first one's done for me. That tells me that t equals 0. If I solve the other equation, by adding 8 to both sides, I get that t is equal to 8. And so that corresponds to my two solutions on my graph. So this would occur when t equals 0, and then this solution occurs when t is equal to 8. And since I'm interested in where they collide after the initial launch, I'm going to be looking at that 8 seconds. Another way of checking this would be to make sure that your answer is within the domain of that missile. And so again, you want to make sure that you use appropriate units. Because our time is measured in minutes, I want to say 8 minutes. So they collide. It takes them 8 minutes to collide. Okay. Now, if those of you are kind of uncomfortable factoring out a common term, we could also look at this as a trinomial. And if you think about it that way, it would be t squared minus 8t plus 0. We can still use our product sum method. Our product would be negative 8, and our sum, I'm sorry, that's wrong. Our product would be 0, and our sum would be negative 8. And the only way for your product to be 0 is if one of those numbers is 0. And so if one of the numbers is 0 and I want to add it to something to get negative 8, that means my other number has to be negative 8. And so that means that I would have t minus 0 times t minus 8 equals 0. And then at this point, if we set each factor equal to 0, I'd get the same thing that we did before. We're just looking at it from a different perspective. So I'd still have t equals 0, and over here, if I add 8 to both sides, I get that t is equal to 8, which is the same thing as I got down here. So if you're not comfortable with factoring out a common term like I did in the first example, you can still factor it like you did before. You just have to replace your c value with a 0. Okay? In number 6, this is also a constructed response problem, and your answer is going to be scored on a 5-point rubric. There's 2 parts to it, and this problem can be done with factoring or division. So if you know how to do long division with quadratics, then that would be another way to solve this problem. But if you want to justify whether or not 3x minus 1 is a factor of the given expression, you can also just factor the expression and then see if 3x minus 1 is one of the terms. So if I think about my expression, 3x squared plus 5x minus 2. The product here is going to be negative 6, and the sum is 5. So I'm looking for numbers that multiply to give me negative 6 and add to give me 5. So you might start off with negative 2 times 3 or 2 times negative 3, but remember 6 times negative 1 and negative 6 times 1 also work. You want to pick the pair that when you add them together is going to give you 5, and that's this pair here. Now we have to be careful when we're factoring trinomials when our a value is not 1. And there are several different methods that you can use. I know Miss Weibel uses a slip slide divide or Swedish fish, I can't remember the name of it. I showed my students a method where essentially you just, we're used to doing like x plus 6 and x minus 1. If instead we just did 3x and 3x, and then plus 6 and minus 1. I do have a problem when I do it this way, because if I think about what would happen if I FOILed it back out, 3x times 3x gives me 9x squared, which means I have an extra 3. So to compensate for that extra 3, I need to divide out a 3 from one of the terms, and it needs to be able to come out of both numbers. So if I take that first expression and divide both terms by 3, I'm left with x plus 2 and 3x minus 1. And so this would be equivalent to the expression that I started with. And since I can see that 3x minus 1 is within that expression, I know that 3x minus 1 is a factor. In part B, it's a very similar problem. It says, suppose the area of a tarp is represented by the function, and notice again, we're given a quadratic function in standard form. And we know that 4x plus 1 represents the length. Well, think about what area represents. If area of a rectangle is just going to be length times width. And if we know the length, we can figure out the width. Now, again, you can do this through division, Or we can simply just factor the expression 4x squared plus 13x plus 3. My product, remember, is going to always be my a times c, which is 12, and my sum is going to be 13. So I'm looking for numbers that multiply to give me 12 and add to give me 13. Well, that's just going to be 12 and 1. And again, because my a value is not 1, I've got to remember that there's a 4 there. So I'm just going to go ahead and do 4x and 4x, but I've got to remember I have an extra 4 that I'm going to have to pull out. And then I can go ahead and do the plus 12 and the plus 1 like I'm used to. But I got to pull out the extra 4. And that can come out of that first expression. And remember, I've got to divide it out of both terms. So that means that I'm going to have x plus 3 times 4x plus 1. I already knew that 4x plus 1 represented my length. That means that my width has to be x plus 3. And if I know that the length of my tarp is 9 feet, we're asked to determine the area. Well, if the length is 9 feet, that means that we said, remember, that the length is equal to 4x plus 1. And if 4x plus 1 is equal to 9, then I can figure out the value of x. So if I subtract 1, I'm going to have that 4x equals 8, so x is equal to 2. And once I know what x is equal to 2, I can plug it back into my original formula to find the area. That means that my area is equal to 4 times 2 squared plus 13 times 2 plus 3. You could also plug it into your length and width expressions and then multiply them together. So there's a couple different ways that you can do this. Well, 2 squared is 4, and 4 times 4 is 16. I know that 13 times 2 is 26, and if I add 3, that total, when I add those numbers together, is going to be my area. Well, 16 and 26, that's going to be 36. 42 plus 3 is going to give me an area of 45. And since I'm dealing with feet, I need to make sure that I'm using appropriate units for area. And since area is 2-dimension, I want to make sure that I call that feet squared. Okay, and that takes care of the next part on factoring.